not an industry expert, I'm an academician. So I'm going to give you a tutorial on the technologies that are currently hot and that what a SME would want to use for their business to improve productivity, to move forward. Key technology trends that can accelerate your business in 2018. That's the topic I was given. To start with, what is already there. So it's the internet that really changed things as far as business is concerned. With the internet now, we can reach out to a wide audience fairly easily. We can set up a payment gateway. You can use web advertising, as you know, it's very cheap. And you can tie up with marketing aggregators, like these Policy Bazaar for insurance, Trivago, Zomato. These are the names you and I see on the net all the time, but there are so many others through which you can do your marketing. And you can also sell through online retailers if you are in the retail. Your output is in the retail sector using Flipkart and so on. So the net itself has made things so much easier than when there was no net. The amount of investment that you had to do to market your products itself has seen a sea change. Is that what I'm trying to show in this slide? The mobile phone is the next level where the interaction is happening, and of course here there's so much to talk about, but you as a business organization, you can create an app for your business to allow mobile phone users to use your website, do business with you, and so many other things. And you can of course market using the mobile, which is very irritating for people who don't want to get those messages, right? Then there's a thing that's a free and open software is now become very big, and there's so many industry class software available for a small business to use without therefore having to pay huge amounts. So these are just some of the major ones. As you know, Firefox is a browser, and the MySQL database, Linux, various versions of Linux shown here. OpenOffice is the Office equivalent. WordPress, as you know, is a blogger, Java, and so on. And there's an Apache small below there is got a huge number of open source software businesses can use. And so this is another peg, if you will, into the inputs that a business gets from day one to get going. Then the issue is about cloud computing, because you need to also put your business data, your processes on computers now. After all, you're using the internet. The website is one thing, but that's not enough. So we need to put things. In the earlier days, we would buy our own computers. We have a data center in our office. We have to manage it. We have AC, fire, fighting equipment, security. Now all that is no longer required if you go to the cloud. So what is the cloud? Just next few slides, very briefly, we go through that. There are lots of things, of course, happening there. But I'm just trying to briefly highlight the issue. So the shared pool of configurable computing resources at one central point, and on demand through the network, you can access those computing resources. And some service provider provides those resources. The service provider typically will have a building or a set of buildings, which we call a data center, in which these configurable computing resources will be housed. And you, as a customer, will get access to them, and you pay for usage as you pay as you use. So inside the cloud, you will have servers, storages, and then they will be interconnected through a network within the cloud. There will be applications running on top of it, and you will access this whole thing through a network connection. To make best use of these resources, a key concept is virtualization. So a virtual workspace is an abstraction of an execution environment that can be made dynamically available to an authorized client by using well-defined protocols. So you have resources like CPU, memory, you share them. Earlier, you would have to buy your own server, which will be dedicated to your work, you will house an OS. But now, we will no longer need to do that. Physical servers can be shared among a number of different customers, and this is basically what virtualization is about, and this is what VMware is all about to begin with. Of course, VMware has now moved well beyond basic virtualization, as of course they will tell you. So just a picture at the bottom over there tells you that there is a hardware, and then there's something called a hypervisor. That's where the VMware, hypervisors first came into prominence, and then you have different OSs running on top of it. So one server with 3 OSs shown here with 3 different applications. So we implement on a virtual machine. So we abstract. A virtual machine is like a physical host machine, as if you have a physical machine and there's a small OS called a hypervisor running below your OS. So if your OS is, say, Windows, below the Windows is running on the virtual machine. So but the Windows things is running on hardware. So whenever it makes a call to hardware, it is the hypervisor that intercepts the call and does the work on behalf of the OS, host OS, which is Windows. And so these hypervisors, VMware and so many others are there on the market. Some are also open source available. You can play around with them too. We'll come to that a little later. And with this infrastructure now, users are given virtual machines. The provider buys physical hardware as and when required, increases the hardware, and you as a customer don't have to worry about all that. So again, to reiterate, virtual resources create on top of physical resources. We have virtual CPUs, we have virtual storage, virtual network to interconnect these virtual CPUs and storage. So if you have, your requirement is not just one server, you are a bigger company, you have lots of services, then each of those services may be running on a separate virtual machine, virtual CPU, and there may be separate virtual storages, and you need to interconnect them all. And these, as we have said, these virtual resources are created on demand. Again, similar picture, slightly bigger version of what we saw earlier. There's a hardware at the bottom, there's a virtual machine hypervisor, and these are the standard major hypervisors today: Zen, VMware, Hyper-V, Oracle Virtual Machine, KVM. And on top of that, you have the guest OSs. So they're showing you Linux running, NetBSD running, Windows running. So these are running, the OS is running without any change. So it's running as if on hardware. And that is the advantage of having virtualization, that your application and OS which ran on the hardware, on a physical hardware, will run without change on a virtual machine. Of course, the device characteristics drivers have to be there, which are taken care of by the virtualization layer, the hypervisor. And example of a public cloud, all of this is also called the cloud now. And a public cloud is where the resources are shared among many customers, and the most famous of them is Amazon Web Services. And you can, for example, storage, you can get storage as you use it. You can use, there are things like this. As you can see, this is some pricing model of number of bytes transferred, number of bytes stored per month, and so on. Okay? And of course, the pricing models are a huge number of different types of pricing models. Then the storage itself, it's virtual, but there are quality of storages with technology. So these are some of the things that I've picked up from AWS. So they have a general hard disk-based storage for you. You say you want so many gigabytes, and you install your file system or your database on it, or you want a solid-state device-based, because you've got a database, your load is so much, you need a number of separate virtual instances interconnected through a cluster, and what you normally do on a hardware, you can do it here too. And then you can attach storage, which is you have already obtained as an elastic-based storage, and then you can install your own OS on this virtual machine, or the provider itself provides you an image of the OS. You want Linux, you want Windows, they will provide you at the price, of course. And so what is cloud computing? Therefore, the platform provides an on-demand services that are always on, anywhere, anytime, any place, pay for use as needed. Elastic. You scale up and down in capacity and functionalities as you need. Okay? And there are many versions of it, of course. There are many nuances to it. Let's try to see what I can cover. So, to begin with, early days, there would be a data center, but you would have what's called a hosting service only. That I would, as a company, buy my own hardware, but I don't want to handle the air conditioning, the fire, and the manpower, and the security. So I put all my servers in the data center. So customers' computing resources are kept hosted in the provider's data center. Customer doesn't have to worry about all the stuff I mentioned, and customer obtains a network line to the data center, and the management of the hardware could be done by the customer, or it could be outsourced to the provider also. So this is called the hosted environment, where your hardware is being kept by the service provider. But that, strictly speaking, is only in a way, the step 0 of a cloud. So now, next step you do is an infrastructure as a service. So here, the provider has computers, storage, network in its data centers belonging to the provider. And the provider offers virtual resources to the customer on a pay-per-use basis. This is the kind of thing I just showed you about AWS, Amazon Web Services, is an example of an IaaS, infrastructure as a service. Customer doesn't need capital investment, customer loads these are all already seen this. Now, this is first level. On top of that, we could have what's called a platform as a service. That not only does the service provider give you a virtual machine, but it also gives you an environment on which you develop your applications. So, for example, Google App environment is there, or open source can have an Eclipse environment. So the programming language along with all the libraries are already loaded and available. You have to program it. You have to write your own program. So the platform is given. It's not just the Linux or Windows, but the development environment is what is being provided as a service. And that's called platform as a service. Platform as a service has not really taken off as much as IaaS and software as a service. So the final level is what's called the software as a service. That the software which normally sits on your desktop or in your server in your company will now be running from the cloud. The provider provides applications for customers to run and use. The same application may be shared by many to a multi-tenant software, or it could be an exclusive copy. So, for example, you have Microsoft Word running as a service. So you could have your own instance of Microsoft Word running only for you, or one instance is running and multiple users are editing their own files. So obviously, the second will be cheaper, but you may be worried about security and other things. So various such issues are there. Okay. Now the software as a service provider may be different from the data center provider. The SAS provider, in fact, could itself obtain IaaS or PSS from the data center provider. So lots of different models of providing these services are now available. The hierarchy of, in fact, providers. So this picture is just putting it all together with some examples here. So at the bottom we have infrastructure as a service, Amazon Web Services, Microsoft Azure are the two prominent ones. And then platform as a service, as I said, Google App Engine, Heroku is another private company which is coming up. And then software as a service is picking up real fast, and all the big players are already there. Microsoft Office 365, Microsoft has Outlook, email services, and Google Apps have everything, right? And then the CRM from Salesforce is another example shown here. So all of these are software which you don't buy, which you use and you pay per use. Another thing is now you want to run your business, you want ERP, you want finance, you want procurement, you want inventory, you want HR. You don't need to buy the software anymore. You can do it and you can have ERP as an SAS. So here's an example of Indian SAS. TCS has a software called ION, which is targeted towards SMEs and education institutes. So some of the stuff for an SME, it has already finance and accounts, procurement, inventory, HR, production management, sales management, quality management, maintenance. So all of these modules are already there, and you pick and choose what you need, and they will set it up for you, and you pay monthly, quarterly, or as per use. Different models are there. And you don't have to do anything in terms of IT infrastructure, except that you got to have your desktops and you got to have a network connection. Now moving forward, new things are happening. This is a standard thing already there. New things are happening. The buzz is big data. Large amounts of data are now available to businesses. This is due to increasing digitization of business. Now, storage of large amounts of data is an issue. So, also using this data usefully is an issue. And analyzing this data analytics is a new field spurred on by the availability of large computing power. Normally, analytics takes a lot of time. It was very time consuming, but now with new hardware, especially with GPUs, which were originally meant for graphics processing engines, are now used for stuff like data analytics. So very quickly, what do you do with big data? You want to collect and store it. You have to retrieve and analyze, decide, predict and decide, learn, recognize, decide. All of these things are what businesses are talking about doing with big data. How do we do it? We do it with analytics. And now data analytics is itself available as a software as a service. And here's an example of IBM Analytics on the cloud. Just a few things that, for example, their system can do. It provides you business intelligence, gives you reports, dashboards, etc. It gives you enterprise performance management solutions that span finance, sales, operations, transform systems of engagement, gives you an overall picture of what is happening. It will give you predictive analysis, statistics, modeling, data collection solutions, combine data to derive a full and more accurate picture of customers, operations, threats, fraud, and more. Or, going further, prescriptive analysis, powerful foundation for decision making that takes predictive analytics to the next level by helping you to choose what action to do next. So here some intelligence is now coming in. The computer is going to tell you what to do rather than give you the information on which you can decide what to do. And of course, the other things are risk analytics is also there. And this all brings us to machine learning. This is another buzzword. So what is machine learning? This is a very small cartoon telling you what machine learning is. Very simply put, traditional programming, you feed data and a program, the computer runs the program and you get an output. In machine learning, you feed data and you feed the predicted output, the output that the data should have, and the computer comes up with a program. And that program is now fed on the top part with new data, and you then find out what the output is. So, in machine learning, the computer learns. Given sample data and sample output, computer learns. And therefore, you can say the computer has produced a program. And that learning is then used to look at new data and say what is going to happen. So, machine learning is used in face and handwriting recognition. It basically is used in recognizing patterns. So, it can be used in various fields of business and commerce. It can help us in indicating faults, indicating trouble. It can help us indicate new behavior. It can help us recognize patterns that we did not know existed. This area is called data mining. And then you can use all of these to increase your productivity tremendously. I don't have time to give examples here, but it's an area where it's being applied everywhere, so to speak. And following to this, of course, is artificial intelligence, the other buzzword. I'm having to move very fast because you're all very intelligent and I'm running out of time. Okay? So, natural language generation, creating speech, producing text from computer data, currently used in customer service, report generation, summarizing business intelligence insights, speech recognition, transcribe and transform human speech into format useful for computer applications, currently used in IVR systems, mobile applications. Virtual agents, bots. The current darling of the media, says Forrester. I believe they refer to my Alexa is a bot. It's what is from simple chatbots to advanced systems that can network with humans. So basically, these are human-like entities to which humans talk. So your today's BPO person on the other side will be replaced by a bot, and you won't know the difference because there is speech generation, there is talk, they can understand what you're saying, and so on. And of course, robots are also a big process automation, manufacturing. It's a huge thing. It's been going on for some time. Robots are ubiquitous now in most assembly line manufacturing. And there too also, basically artificial intelligence are required. And when movement, etc. is there, then of course robotic AI comes in heavily. Then, analyzing text, learning language is also a big thing. And robots, here's the big buzz, of course, driverless cars. All of these technologies are getting into this thing if you want to really have a driverless car. Then, finally, there's the Internet of Things. Putting it all together is the Internet of Things. What is this? We are putting computing elements embedded in everything. So that's why I say Internet of Things. Things are getting connected, not machines anymore. And these things, these embedded items are basically contain sensors to pick up parameter data of the thing. It forwards the data after minimal processing to a central controller. There may be a hierarchy of controllers. Then you receive commands from these controllers to change parameters, to initiate action. And therefore, you are able to control and sense your environment. And you can do lots of things which you could not do earlier because of this technology coming in. Of course, this is still a work in progress and things are happening very fast. So one of the things it makes things smart, it enables smart systems. So the buzzwords of smart cities, smart home, smart manufacturing, maintenance, agriculture, energy, transport, everything is becoming smart. So you can get an idea what's happening in any one of them. You are putting these IoT devices in the home. Every part of your home has an IoT device, and the controller is sensing the fridge, the lights, the door, and everything is automated. That's what is a smart home. Just take it one level up to a city, and you can imagine what's going on. And that's all I have time for.